Welcome to another unit of the ISM exercise set Business Mathematics. This time with a unit on derivatives. Let's take a look at the exercise. Here we have calculate the first and second, here partial, if necessary, derivatives of the following functions. The first one is f of x and y being x times y plus x divided by y. So here we have two variables, meaning we need partial derivatives. And the second one, that's f of x, being 1 divided by 1 plus x. So here just first and second derivative for x. Okay, let's work our way through the two examples step by step, starting with the first. So we start with the first part, our exercise A. Here we have the function x times y plus x divided by y. Well, to make this easier to get our especially first, but then as well the second derivative, we rewrite the second term. So instead of x divided by y, we write this as x times y to the power of minus 1. We can do this whenever we have something which is written as a fraction. Okay, with this in mind, we can directly turn to the first derivative. Well, here we have the result. How do we get this? Well, we start with the equation and go for the derivative for x. So we start the first part, that's the x times y, derive this by x, so we're left with y. And if we derive this with y, we're left with x. So that's the first term in both of the two derivatives. Then we get to the second term. Here, when we get the derivative for x, well, x derived by x is 1, so we're only left with the y part, so it's only y to the power of minus 1. This then gives us the first derivative for x. That's y plus y to the power of minus 1, or 1 divided by y. Okay, for the derivative for y, we actually have to do some extra work. Here, we keep the x of x times y to the power of minus 1. Then y to the power of minus 1, we pull the minus 1 in front of this and subtract 1 from it. That's the rule for working with polynomials. Always reduce the exponent by 1 and pull the original exponent in front of this. Here we have a minus 1 which we pull in front of this, so we have just minus the resulting term. So we have minus, the x remains, and then y to the power of minus 1. If we again rewrite this as a fraction, we get x minus and then x divided by x to the power of 2. So again, the minus in the exponent just makes this a fraction and puts this below the fraction line. Okay, so much for the first derivative. For the second derivative, well, the first one, we take now here our derivative for x and derive this for x and for y. So if I start in the upper left of the Hesse matrix, I have the derivative twice for x. Well, the derivative for x already doesn't contain any x's anymore, so the derivative here is 0. So that's pretty easy, straightforward. Then we take the same derivative and derive this for y. Then we get the upper right entry for the Hesse matrix. So here we have y derived for y, that's 1, and we have y to the power of minus 1 derived for y, which here would just mean we pull the minus 1 in front of this and subtract 1 from the exponent, giving us minus y to the power of minus 2, or here 1 divided by y squared. Okay, so much for the derivative where we started with deriving for x. Now we take the second one. Then we take the derivative for x, so first y, then x. Then we have x minus x times y to the power of minus 2. Well, if we derive for x, just the first term gets to 1, and the second term we just lose the x. So we have 1 minus y to the power of minus 2, which basically is the same as it has been on the upper right. The only thing where we actually have to do some additional work, if we want to get the derivative on the lower right, which means twice for y. So we take the derivative for y, which is here the x minus x times y power of minus 2, and derive this for y. If we derive x for y, we lose this because there's no y in it, so it gets to 0. Then we are only left with minus x to power minus x times y to the power of minus 2. The minus x remains. We pull the minus 2 in front of this and subtract 1 of it. So minus 2 becomes plus 2x. Then we're left with y to the power of minus 3 because we subtracted 1. Then, well, we rewrite this again as a fraction, so we have 2x, and then y divided by y to the power of 3. Well, this then already concludes the first part of the derivatives, and we can turn to the second one. In the second part, we had here the function f of x being 1 divided by 1 plus x. And we have a fraction, thereby we're going to use the quotient rule. For the quotient rule, the part above the fraction line, so our denominator is 1, so the function g is 1. The function h below the fraction line, here is 1 plus x. So to get the first derivative, we need to get first the derivatives of g and h. So here, as I said, g is 1, so the derivative of g is 0. Then we have h being 1 plus x, and the derivative of 1 plus x for x is 1. Then we can just combine these parts, giving us, first off, the derivative of g times h, so 0 times 1 plus x, so being 0, minus g, so 1, times the derivative of h, also 1. So we have 0 minus 1 times 1. So above the fraction line we have minus 1. And below, that's h squared. So here 1 plus x in parentheses to the power of 2. Looking as follows. Then we just need to take this function and derive it again. So we copy this function and again use the quotient rule. Here we have a new g. The new g here is minus 1, but still the derivative is 0. We also have a new h. That's 1 plus x in parentheses to power of 2. Here we can just factor out, giving us x to power of 2 plus 2x plus 1. And the derivative here is 2x plus 2. So we combine this again. So again, derivative of g being 0 times h, so this is omitted, minus, then we have g, so minus 1, times 2x plus 2, so it's only 2x plus 2 above the fraction line. And below we have h squared, so instead of 1 plus x to the power of 2, we have 1 plus x to the power of 4. This looks here as follows. And then we can just remind ourselves that we can get or factor out a 2 above the fraction line, and we have 2 times x plus 1 above the fraction line. And this can be shortened with the denominator, meaning in the end, after shortening this, we have 2 divided by 1 plus x in parentheses to the power of 3, giving us the second derivative of our function f. And this then concludes this exercise, and I hope you enjoyed listening to it. And if you want to see more of this type of exercises, feel free to visit the rest of this exercise set or the corresponding playlist. I say goodbye and see you next time.